Hello. So the question says that which of the following graphs represents the variation of maximum kinetic energy of the emitted electrons with frequency V in the photoelectric effect correctly. So let's try to understand the question, the photoelectric effect in little more detail. Uh, so here is the experimental graph of the photoelectric effect. You can see on the vertical axis, we have the kinetic energy of the emitted electrons. And at the bottom, we have on the x-axis, we have the frequency of the incident light. So in the photoelectric effect, basically we are being monochromatic or monochromatic meaning single frequency light, shining a single frequency of light onto a metal surface. And then we are varying the frequency of light. So as we vary the frequency of light, initially we find that there is no emission of electrons up to a certain frequency, which is also called as the threshold frequency of the material. Beyond this threshold frequency, the kinetic energy of the emitted electron starts to increase at a constant rate. So a graph of the kinetic energy of an injected electron KEE, or the kinetic energy of the electron, versus the frequency of EM radiation impinging on a certain material is shown above. Okay, there is a threshold frequency, so you can see this whole thing. There is a threshold frequency below which no electrons are ejected, which we can see here. F0 represents the threshold frequency of the particular material or metal that we are talking about. Because individual photons are interacting with an individual electron, till the time the photon has till the time the photon has insufficient energy, the electron will not break away from the surface of the metal. Above the threshold frequency Ke increases, or the kinetic energy of the electron increases linearly with F, consistent with this linear equation. Now, if we look at the elements of this equation, the left-hand side represents the kinetic energy of the electron. H is the Planck's constant. F is the frequency of light. And Be is the binding energy, or the threshold energy required to break the electron away from the metal surface. The slope of this line is H, and the data can be used to determine, actually has been used to determine the Planck's constant experimentally. Einstein gave the first successful explanation of this data by proposing the idea of photons, which are actually representing the quanta of EM radiation. So EM radiation in this case, or light, uh, is basically, we are looking at the quantum nature of light. So given this information, we can pick out very clearly the EK, kinetic energy of the electron here is EK in all the four graphs on the vertical axis. The x-axis actually represents the increasing frequency of light. And as you can see, the threshold frequency here is there given, not clear whether it's VT or VE. But once the frequency of light goes beyond the threshold frequency, the kinetic energy of the emitted electrons goes up linearly. So the answer in this case is going to be D. We can mark it out here. D being the correct answer. All right.